Okay, here are the notes for day 9, composition of transformations. Okay, before we start here with any of the notes, just a quick summary of what a composition is. All right, when we say composition of transformations, what we're going to be doing is 2 or more transformations at the same time. All right, so we'll take a point and we'll reflect it, then we'll take that point and rotate it. All right, we'll take a point, translate it, then take that point and rotate it. Okay, so it's 2 or more transformations all done at the same time. Instead of having a part A do this, part B do this, part C do this, we can write these out in a style that's called compositions. So how do I know a composition is happening? The symbol for composition looks like a little degree symbol. All right, you'll see that O right there. Okay, it's a degree symbol. And here is an example of what a composition would look like. Let me just get it down and I'll explain it. We have seen that symbol before, so we know what's going on there. Okay, so here's a typical problem right now done using compositions. And you see again, there's my little degree symbol right here that says a composition is going to happen. Now we know the two compositions, we know the two transformations going on. One's a translation of right 2 down 6, and the other is a reflection through the y-axis. Now the question is, which one do I do first? And here's the big thing you don't want to get caught up on, is that these are completed right to left. Okay, that is huge. All right, completed right to left. So for instance, in this case, we take whatever points we were given and we would reflect them through the x-axis first, take those prime points, and then translate them to -6. So we want to do everything with compositions, starting with the one that's to the far right, and then move our way along to the left-hand side. Okay, so let's try a couple here before we get into points. So I have this letter B on the next one, and you can see the transformation, the composition they give us, because I see the little degree symbol. Now, again, we read them right to left. There's 2 reflections going on. So if you read the one to the right, it says first thing you want to do is reflect B over line L. So everyone go ahead, reflect B, flip it over line L, and draw what your new B would look like. Okay, so there's my new B. All right. And again, let's not get critical here. Mr. Carlino, I think that upper hump is a little bit bigger than the lower one. Let's not go there, all right, just as long as it's flipped. All right, now keep going to the left. And now it says, hey, now you want to take whatever B you ended up with and reflect that over line M. So take that B in the middle and reflect it over line M. And now I have a B in that position. Now, instead of doing 2 reflections here, what could I have done right from the beginning to go from the original B to the B I ended up with? Okay, what could I have done there? All right, so to go from my original B to the ending B, they're the same size, same shape, but it's moved now. So what I could have done, and what is the same as a composition of reflections across parallel lines, that's a translation. Okay, so anytime you reflect over 2 parallel lines, all right, 2 parallel lines, it's the same as doing a translation. Okay. All right, now what if those lines are intersecting now and we want to do the same thing? They're not parallel anymore, but they intersect. What do I end up with? Well, let's find out. So you guys read the directions there. I got my composition. First thing I'm going to do is reflect that letter C across line L. Okay, so go do that. Distance doesn't change. So hopefully it'll look something like that. Okay, now, best of our ability, keep going to the left of your composition. We're going to reflect it over line M now. So fold your paper over line M. What's that C going to look like? something that looks like that, right in that neighborhood. Okay, so that's our final C. So now, just like I asked above, when you reflect over two intersecting lines, how could I have gone right from my original to my ending one? Okay, so if you guys are taking a look, you're probably right. You could have just done a rotation. Okay, so summarizing this all again, when you reflect over two parallel lines, it becomes a translation. And when you reflect over two intersecting lines, it becomes a rotation. One last composition called a glide reflection. All right, that is a composition, and you can sound it. A glide is a translation, and reflection, reflection. So it's translation and a reflection. But one key thing to remember is, do a little quick ghetto graph here. Okay. And I'll just put triangle ABC up here. Okay. The thing is, wherever you slide your figure, okay, so let's say we slide it down, triangle ABC, we slide down here. You have to make sure when it's time for the reflection is always over a line that is parallel to the direction you slide the figure. So see how we slid the figure down here? So I'm going to have to reflect over something that's parallel to that slide. So I could reflect over the y-axis. I could reflect over x equals 1. I could reflect over x equals negative 10, right? But wherever I reflect has to be parallel to the slide. Usually every year when we do this, I take you guys out in the hallway, put some tape down, and we do the glide reflection dance, but that's not happening this time. So again, glide reflection. The order doesn't matter whether you translate or reflect. That doesn't matter what comes first. What matters is the following. Whatever you reflect over has to be parallel to wherever you slide. So again, just to make sure we got this concept down, let's say I took ABC and we're sliding this way. Okay, that means I need to reflect over something that's parallel to that slide. So the x-axis, any y equals a number would be fine. Okay, the slide has to be parallel to the line you reflect over. Okay. All right, now let's actually do some compositions with actual points. So we have triangle text here. If you want to pause the video so you guys can get text graphed, that's fine. I'm going to keep trugging along here. Okay, I see the composition symbol. I got a reflection over the y-axis with a translation of 0, -5. All right, so like we talked about on the first page, you want to go right to left. So the first thing I'm going to do is I'm going to take all these coordinates, t, e, and x, and I'm going to translate it 0, -5. So they're not going to move right or left, but all points are going to go down 5. All right, so t prime is going to be -5, -3. E prime is going to be -1, -2. And x prime is going to be -2, -4. All right, keep going. Now I'm going to take those points and reflect it over the y-axis. So t double prime now will become 5, -3. E double prime will become 1, -2. And again, you guys can stop the video at any time and try this stuff on your own. X double prime will become 2, -4. Okay, so these are my final coordinates here for that composition. All right, so hopefully we're good in understanding with the compositions and how they work. Biggest thing, right to left, right to left. All right, next up, orientation of a figure. Orientation of a figure, that is the direction of vertices on a figure. Okay, so for instance, I get out triangle ABC. and I go from vertex to vertex. And you can pick any vertex to start with in any direction. So I'm going to go point A to B to C to A and keep going around, all right? This right here would have clockwise orientation, right? Because you can see the clock, just it goes in the direction the clock would. So that has clockwise orientation. If you guys ended up going C to B to A, you would say it'd have counterclockwise orientation, all right? The big thing though is you want to make sure as we go into rigid motions with same orientation now, all right? Rigid motion. So we only have some we can choose from here. All right, so you got your rotations, your reflections, and your translations. All right, which one of those would result in orientation not changing? Okay, so let's go through our options here. Let's go translation. Okay, so go back up to my triangle right now. We had a clockwise orientation. You guys slide that right, left, up, down, diagonally. What type of orientation as you go from A, B to C will it still have? Will it still have clockwise if I slide it up and down, or will it be going backwards now as I go from A to B to C? All right, so you go, let's say we go down and then over to the right. It's still going to be ABC in a clockwise manner. All right, that's not going to change the orientation of translation. So that's why it's considered a rigid motion with same orientation. Okay, what about a rotation? This is always the controversial one. If I turn the figure clockwise, counterclockwise, if I just turn it, will that affect its orientation? Oh, let's try it out here. So let's just take, boom, here's ABC. Obviously a rotation happened. All right, now go A, B. The direction the order you pick originally of letters has to be that same order again. So I'm going to go from A to B to C back to A and hey, take a look. I'm still going in a clockwise direction. So a rotation does not change orientation. Okay, I have 3 listed here. All right. With a reflection. Okay, with a reflection, let me get this out of here now. You're probably thinking, whoa, I think that may change orientation. Okay, let's reflect over this line right here. Okay, so flip that triangle over. And now A prime is over here. B prime is, oops, not B prime. There's A prime. There's C prime, B prime still up here. Now if you go A, B, C, take a look. Now it's going counterclockwise. So you're right. Yeah, reflections do change orientation. So that's why we're going to put reflections down here, but be careful. If you guys remember, I know it's been a while, but the very first day of this unit, we talked about 2 types of reflections. A line reflection, which is what we just did up here. Yes, that will change orientation. But we also reflected through a point on that first day. And if you reflect through a point, that will not change orientation. Okay? So you got to tell me what type of reflection you're talking about to see if it has the same or different orientation. Okay? And then what about the last? I have a number 2 here. What else would change the orientation? Well, a couple minutes ago, we just talked about a new type of reflection where you translate and then reflect over the line parallel to it. Since it's still a line reflection, we can put the old glide in here. Okay. So again, orientation changes the direction of its vertices. All right. If it keeps it the same, we call it same orientation. If it goes in a different direction, we call it opposite orientation. Okay. All right. Next up, I'd like you to pause the video for this one and see what you can do on your own. I'm going from AB. So example number 1, I'm going from ABCD to GHCD. What am I doing? Am I reflecting, rotating, translating, or doing a glide reflection, sliding, then flipping? Okay, so go ahead, pause the video, see what you got. And then when you restart it, hopefully my answers will be there. Okay, so there are my responses. For number 1 was a reflection, number 2 was a rotation, 3 a glide reflection, and 4 translations. Okay. All right. So next part here. Some of you guys are going to like this a lot because it's going to challenge you, and some of you, I don't know how happy you're going to be here. Now you got to tell me what happened. Okay, instead of me telling you, hey guys, take this, do this translation, and do this rotation. Let me know what you end up with. I'm going to show you what we started with and what we ended up with, and your job is to tell me what we did. Okay, so you have to come up with the composition yourself now. So we'll take it easy first. We got a couple multiple choice ones here. All right. So I started with this pentagon A, B, C, D, E. I ended up with pentagon A double prime, B double prime, C double prime, D double prime, E double prime. That was a mouthful. What did I do to get there? Okay. What sequence of transformations happened for me to get there? My best piece of advice for this one is to find a point. All right. So for instance, point B is 2, 5. Okay. And what I'm going to do now is I'm going to go through these multiple choices and ask what they tell, do what they tell me to do here and see if I end up at B double prime. Okay. So number 1, it says we rotated at 90 degrees clockwise and then we follow that up with a reflection over the x-axis. Okay, let's do it then. So I take 2, 5. I turn my paper 1 turn to the left or memorize the rules, whatever you guys decided to do last week. And I figure out that after a 90 degrees counterclockwise rotation, I end up at -2, 1, -5, 2, excuse me. 1, 2, 3, 4, 5, right there. So that's where I ended up at, -5, 2. And then it says, all right, reflect that sucker over the x-axis. I'm 2 units away, so I go 2 units away. Up, look where I ended up. D double prime. Nah. I want to end up at B double prime. So that one, no good for me. Okay, so let's keep going. Next up, still a rotation of 90 counterclockwise, so I end up at -5, 2. But now I want you to follow that up with a translation down 7. All right, let's see how we do. 1, 2, 3, 4, 5, 6. Boom, there it is. I do end up at B prime, B double prime. Okay. Now I'd warn you, that's great that it works for 1 point. I would just test a second point out to be on the safe side. All right. Because, yeah, that rule may work for 1 point, but it may not work for the other points. So please, just to check this and solidify that we're 100% good to go, check it with another point. All right. And that is what I end up with is choice 2. Okay. So let's keep going. Okay. Triangle ABC and RST. What sequence of rigid motions would graph though will prove that those are congruent? Basically, how do I get ABC onto TSR? Okay. So what I would suggest again is getting a point. So I'll take point B now. And point B happens to be -3, 2. And now you got to figure out what's B going to match up with on RST. I always love to use the statement B is going to match up with S, and point S has a coordinate of 5, -2. All right, so let's see what gets us from B to S. Number 1, a line reflection over Y equals X. If we remember, what's the rule? With Y equals X, dig deep. The rule, remember, is flipping the coordinates. And if I flip -3, 2, no chance I'm getting a 5, -2. Okay. I'll skip over the actual answer, which is number 2. Let me go to number 3, a line reflection over the x-axis. Okay, so everyone 2 units away, everyone go 2 units, and I'm right here. So 1, 2, 1, 2, I end up right there. And then it says a translation of 6 right. 1, 2, 3, 4, 5. You end up at a point, but not the point that corresponds with B. So that's out. And then choice 4, which is a line reflection over the x-axis, followed by a line reflection. Okay, so x-axis 1, 2. We're back to this point. Now I want to try to reflect it over the line y equals 1. which, as you remember, is a horizontal line. So I'm not even going to count because it's going to go back up again. It's not even going to be anywhere close to S. All right, so let me get this stuff out of the way here. Come on, come on, come on. Let's go. Let's go. Okay. I don't have patience here. We're good. All right. So now number 2, a rotation of 180 centered at 1, 0. So here's 1, 0. A rotation of 180 is a straight line, if you remember from the constructions. So if I take a straight edge, could I line up point B, 1, 0, and point S? Would that form a line for me? And if you line it up, nice, goes right through. Okay, goes right through. So that is the one I end up with here. Oh, gotta go back on drawing. There we go. Okay. So now what you guys are going to have to do here is no more multiple choice. You got to come up with your own. And I want to stress this. When you write your own composition, there are multiple ways of doing it. All right. There probably will not just be one way to do it. Okay. So on this first one here, trapezoid, A, B, C, D, and then A double prime, B double. How do I get A, B, C, D down to the double prime one? Okay. Again, I would try to take a point, take its image point, and see if you can move them on there. Now, the thing I do want to stress here, this last key point for today, is when it asks you to describe a sequence, that means you need to write 2 or more transformations. You can have more than 2, that's fine. But just saying down 6 isn't going to cut it. All right, just saying rotate 90 isn't going to cut it. You need 2 that are going to map it onto each other. So 2 or more transformations. And hey, you know what? If it takes you 3, if it takes you 4, fine. That's not an issue. The fact is, since it says sequence of transformations, you need 2 or more transformations. Okay? So go ahead, pause the video, try the next 2 out. I'll write my versions up. All right. If they're different from yours, I wouldn't freak out just as long as yours work. Okay. So go ahead, pause the video. I'll write mine up and we'll see where we go from there. Okay. Here's my version. A couple things here I just want to talk about, and it's just really how to write it. You can use the composition symbol like I did here. You can do that. That's fine. It's not needed. You could also write it out in words. You know, for instance, I could have said, take A, B, C, D, rotate it 180 degrees around the origin, followed by a translation of down 2. That would have been fine. Okay, so you can do it in words too. You don't need to do fancy with the symbol. And also, make sure you tell me if you do write it in composition notation like I did, make sure you tell me what the starting one is, all right, what the starting figure is, all right, because that, you know, do I start at A double prime, B double prime, or do I start at the A, B one? All right, so just make sure if you do write it in composition format that you tell me which figure you're going to do it on. And down below, again, not the only way to get ABC onto DEF, but I said, hey, let's reflect it in the y-axis first, triangle ABC, and then take that and reflect it in the horizontal line y equals 2. Okay. Again, you can get creative. It just has to be 2 minimum you need to do. You can do more than 2. Okay. So hopefully when you guys go practice page 41, 42, and 43, you'll get a better feel for this, because this will, no pun intended, translate into what we're doing tomorrow. Okay. You have to have the ability to describe your own sequence of rigid motions, all right, to come up with them on your own. Okay. So good luck on that packet work, and we'll talk at our next Google Meet.